Hi. So the previous module, I hope you can understand about the transistor concept, that why transistor is called the transfer resistors. Now today we want to know about the transistors symbolic representations, transistor schematic representations, and through that we can understand about that how we can generate the transistors symbol. And I want to guarantee these things first time to you that uh, whatever I am saying you about the transistors today, if you can just listen this particular video, then in future you never forget about the how what is PNP and what is NPN transistors and how it can be drawn. Majorly we saw that some of the students, maximum numbers of students, are not capable to draw the transistors properly. They are very much not confident about to draw the transistors properly. So for that point of view, I have to generate this particular video to understand how to draw the transistors, how to generate the schematic diagram, or how to develop, how to represent the symbolic approach of the transistors. I know that as an engineer, electronics engineer, this is very much mandatory for you to understand about the symbolic representations of the transistors. And you have not only the symbolic representations of transistors, any kinds of circuit, if you just develop it in the errorless, then you will be a good engineer, good electronics engineer. So be careful, you show these things about the transistors concept. So first of all, I want to just represent it very easily, that PNP and NPN concept. We have already know about that, this PNP and NPN. Suppose PNP, and here it is the NPN. This is PNP and this is NPN transistors. Suppose this is collector, this is emitter, and this is the base. Suppose this is collector, this is emitter, and this is the base. So base, emitter, collector. So collector, emitter, base. Collector, emitter, base. Okay, very good. PNP junctions. PNP or NPN junctions. Okay. Now, as I know that some of you are developing the transistors, how we can represent the symbolic approach of the transistors. How we can represent this transistor, that is the PNP transistors. PNP. PNP. Okay. Now, I'll just represent the transistors in here like this, this, and this. Base, collector, emitter. Very good. Now the things is that base, it is collector and emitter, and P to N, emitter to base, you show what kinds of things is that. That is the P to N formula. P to N formula. That is the P to N formula. I am again repeat, P to N formula. You show this is the representations of the transistors, and P to N, that means arrow always from P side to N side. In the arrow always in the emitter positions, emitter side, but P to N side. That means the arrow is here. You show P to N. The rules is that P to N. And again repeat, that is the PNP transistors, that is the PNP transistors. There is a base, there is a collector, there is a emitter. You show there is a collector, there is a base, there is a emitter. Everything's the same. Okay, very good. Maximum students are forgetting that how we can define its PNP or NPN. At that time they are just confused. I am just saying you, this is the concept, that P2N concept. P2N concept. P2N concept means it is the looks like transistor. Arrow is present in the emitter side. Arrow is the emitter side, present in the emitter side, and arrow directions from P to N. Arrow directions is always from P to N. You show the arrow directions P to N. Arrow is present in the emitter side. Emitter side, in the side of the emitter, the arrow is present, and arrow is from P to N side. P to N side. P to N side. You show the P to N side. Arrow is the P to N side. Now we go for the another particular diagram. Another particular diagram. It is also another particular diagram is also looks like that. This is the collector, this is the emitter, this is the base. Collector, emitter, base. Now the arrow is present in the emitter side. Arrow is present in the emitter side, and it is P to N. P to N. That means it's P to N. P to N. Arrow is present in the emitter side and P to N. Arrow is present in the emitter side and P to N. So this is the one NPN transistor, and this is one PNP transistors. This is one NPN transistor and this is one PNP transistors. My dear students, some of you are drawing a different kinds of transistors. Whatever in my experience, I am just drawing all different kinds of transistors you have drawing in your examinations or any kinds of report sheet or assignment. These are some of the students are developing. Transistors are developing like that. They are developing the transistors like that. There is no any arrow. Some of you are developing the transistors like that. Some of you are developing the transistors like that. So this type of different kinds of transistors in my life I have seen. I seen some of you are representing the transistors like that, and also several some of you are just in apart that there is some circle. They are also asking me this question, if there is no circle, then it is transistors or not. So these are the different kinds of transistors. These are the different kinds of transistors which is developed by and confusedly developed by several students. But these are all wrong. The right process is this. You always fundamentally clear about these things, why it looks like that. That is the P2N formula. That is the P2N concept, and why it looks like this. That is the P2N concept, and I would like to request all of you to understand about this particular two concept, that how it is developed, how it is P2N concept, how the P2N concept is developed, how the P2N concept is developing here. By this concept, we can very easily understand and define the transistors. We can very easily draw the symbolic representations of the transistors. Thank you very much. Hi. So in the previous video, you have already shown about that transistor symbolic representations. It's the very easiest way I just explaining you, and I hope that you have already enjoyed on that. Now the things is that the today's lectures is very much important. On this particular module, we are concentrate about a very important explanations of the transistors, and through this particular important explanations, any kinds of transistor circuit, any kinds of transistor concept you can able to develop, any kinds of complicated circuit of the transistors you can able to represent. So what is the concept? First of all, for that reasons we have to represent two things. There is some of the books are represent obeying the current analogy, and some of the book there is another representing of the electron analogy. Now what is current analogy, what is electron analogy, I am just explaining that. Suppose we all know, if the electron is moved from this side to this side, if the electron is moved from this side to this side, so current is moved from this side to this side. Okay, so we can able to represent this current as a current is flow from this side to this side, or we can represent it as the electron is flow from this side to this side. So and also I am saying you, suppose there is a switch, I am just on this switch and this light is on, and very simply as an engineer what I am saying, just I am on this switch, for that reasons the path is open, the current switch is on, and for that reasons current flow from here to this bulb, and then automatically bulb is glowing. These things we have saying. And this is one of the representations, this is the representations of the current analogy. And another analogy is that, suppose there I am just representing the light, and for that reasons the bulb is for that reasons the electron flow from this side to this side and bulb is going. So this is the electron analogy. There is also another very complicated analogy. One things I want to say, that electron analogy is also very good, because some of the case the electron analogy is useful for the electronics purpose things. But today's lecture we just concentrate, for simplified versions we have to represent it as a current analogy concept. We have to concentrate about the current analogy concept. So for that reasons we have to know that a very simplest way of the transistor by which we can able to understand any kinds of transistor circuit, any kinds of transistor circuit. I know in several books several types of explanations are there. I know several teachers and several video they are explaining in the several way, but this is the another way, this is the another concept I want to impose, I want to introduce to you. I hope you will enjoy. The things is that, suppose I am just considering one transistor's parts. This is the NPN transistor. This is called the NPN transistor. This is collector and this is emitter and this is base. This is NPN transistors. It's a gentle NPN transistor. Okay, very good. And I have already said that I am always concentrate about the current analogy, and whatever my lectures you have shown, I am just concentrate about the current flowing concept, not the electron flowing concept. I am just introducing only the current flowing concept. So in case of these particular transistors, and I just today I am just explaining one particular term statement. By this statement it can be possible to simplify the transistors for any kinds of complicated circuit. The statement is base is called current control pin of the transistor. Base is called the current control pin of the transistor. If I increase the current in the base, then collector to emitter resistivity decreases, huge current flow from collector to emitter. I am again repeat, I think you confused about that. I am saying that base is called the current control pin of the transistor. It is the pin, basically transistors have three pins. One is the collector, another is the emitter, another is the base. And I am just practically represent you that base is called the current control pin of the transistor. If I increase the current in the base, then collector to emitter resistivity is decreases, huge current flow from collector to emitter, I am again repeat you that base is called current control pin of the transistor. If I increase the current in the base, very nominally, if I increase the current in the base, collector to emitter resistivity decreases, huge current flow from collector to emitter, I am just giving you very simple example. I think you can understand. I hope you can understand that what is the diagram of this. Yes, this is the tap call. This is the tap call. The water is coming from this side and water is outer from this side. Okay, and this is the base. It is the collector and it is the emitter actually. And again I am coming to this particular matter. This is the analogical representations of the transistors. That is, the water is coming from here and it's go to outside. Suppose this is the collector and this is the emitter. Okay, now base is called the current control pin of the transistor. If I increase the current in the base, that means I am opening the what tab. I am opening the what tab. And if I am opening, then collector to emitter resistivity, this is the resistance it's giving, the resistivity is decreases and huge current flow from the collector to emitter. The tap call concept, very simply tap call concept. If I increase the current in here, if that means I am opening the tap call. If I am increase this, that means I am opening the tap call. If I am opening, then collector to emitter, a huge current flow, a huge water coming from this side to this side. Consider this is collector, consider this is a emitter and this is base, and introducing the current in the base, that means I am opening the base in here, opening the tap call in here, and a collector to emitter, a resistivity of the collector to emitter is decreases and huge current flow from collector to emitter. Such as like that, if I am increasing very small current in the base, then collector to emitter, a resistivity is decreases, and for that reason a huge current flow from collector to emitter, So like this way, in case of any kinds of complicated circuit of the transistors, is possible to understand. Any kinds of big circuit of the transistor can be possible. I know that it is a switching concept, but things is that this is the theme of the conceptual theme of the transistor. By this way, we can very easily utilize the transistors in different places. So I am again repeat this particular statement, and you have to remind this statement for your lifetime. That is, the base is called current control pin of the transistor. If I increase the current in the base, collector to emitter, resistivity, yes, decreases and huge current flow from collector to emitter. Thank you very much.